Hello, this is Group 5's presentation for EME 303. Our topic will cover the fluid dynamics of tornadoes, essentially what tornadoes are, how they form, and how material we have learned in class can be applied to tornadoes in real life. Here we have a video of a tornado lifting a vehicle and influencing its movement that I'll play first. Obviously it's not a good idea to drive during a tornado, but as you can see, the force from the tornado is so strong that it affects the car by lifting it up for a brief amount of time. So tornadoes come in different shapes and sizes, and there are different factors that determine those qualities. They are not classified by those qualities ever, but rather their max wind gust speed over a time span of 3 seconds. The EF, or Enhanced Fujita Scale, is used to assign a rating to a tornado, again based on its speed. The table in the bottom left corner details the ranges of wind speed that correlates to each EF category. And so tornadoes typically occur during the evening and move from southwest to northeast, but they can move in all sorts of directions. Their horizontal speed can change sporadically, which is why they're so dangerous and unpredictable. And in America, they usually occur in warm, dry, and flat areas. The definition of a tornado is the specific combination of winds during a thunderstorm, which then results in the tornado itself. So first off, the air begins to spin when the wind's blow in different directions, and then that air starts to rise and it begins to get pushed to the side by the wind. The air that rises starts out as warm, and then it'll cool rapidly, which kind of gives energy to the tornado. And then the spinning air near the ground will then speed up as it is sucked inwards towards the axis of rotation. And this diagram here is a good depiction of that. And a little fun fact that we found is that humans and animals have been recorded to have traveled over a quarter mile in a tornado without being harmed. And I don't know what happened after the quarter mile. So when air is drawn inwards towards the axis of rotation, the tornado will begin to speed up. A good analogy of this is a figure skater pulling their arms inward when they spin. So when their arms are stuck out, as seen in this diagram here, their rotational inertia is greater, which then causes their angular velocity to be smaller. So when they tuck their arms in, their rotational inertia decreases while their angular velocity increases, which is why they spin faster. And this relationship is due to the fact that the conservation of angular momentum. And then next, the wide surface area on the base of the car allows the fast-moving winds to apply a force against the bottom, and force equals mass times acceleration, but in angular terms, acceleration is v squared over r, and that force allows it to pick it up into the wind streams. And the Archimedes principle states that an object immersed in a fluid, which this case is air, is buoyed up by a force in that fluid. The force that picks it up is F equals rho gh. And a large object like the vehicle in the video that we saw is subject by this buoyant force and then lifted up. Tornadoes are columns of air that rotate at extremely high speeds due to changing wind currents, and with enough force against objects with larger surface areas, such as the car that we saw in the video, tornadoes are capable of moving large and heavy objects for far distances because they are so powerful. The large acceleration of the wind speeds in the tornado will result in a large force, um, F equals ma, and then that said force will carry the object upwards due to the buoyant force, which is F equals rho gh. And it is recommended that people take shelter in buildings instead of cars as a result of this larger force.